Okay, we've already set up our linear programming problem and graphed it and found one of the vertices. So let's go on to the next vertex here. This is the intersection of equation 1 and equation 3. So I'm going to set up a system of equations for 1 and 3. And when I go back to my original problem, equation 1 will be y equals 2. So y equals 2, and equation 3 will be 2x plus y equals 6. So 2x plus y equals 6. This system can easily be solved by substitution. So I'll substitute y equals 2 into that equation 3. So I have 2x plus 2 equals 6. Subtract 2 from both sides, I get 2x equals 4. Divide both sides by 2. We get x equals 2. So the ordered pair for that vertex is going to be 2 for the x and 2 for the y. We can go back and label that on here, on our graph. 2, 2. And then we just have this third vertex to find, which is the intersection of line 2 and line 1. So I'll set up my third one. Equation 2, oh, I should put 1 first. Equation 1 and equation 2. Equation 1 was y equals 2, and equation 2 was x minus y equals negative 3. Again, I'll substitute the y equals 2 into that second equation. So x minus 2 equals negative 3. Add 2 to both sides, I get x equals negative 1. So that tells me the vertex is at the ordered pair negative 1 for the x coordinate, 2 for the y coordinate. So we'll go back and label that. Negative 1, 2. Now a lot of times you can look and see where those vertices are going to be, especially if you're using graph paper, but like I said, I prefer to just use plain white paper so that the graphs look neater, and so you can't really tell just by looking. But you should still eyeball to make sure that the points that you're finding actually look correct to the graph. The third step for linear programming, step 3, is that we need to take those vertices and figure out which one gives us the optimal value or the max or min value for our objective function. So step 3 is to substitute each vertex into the objective function. Our objective function that we started for this problem was f of x comma y equals 5x plus 2y. So remember, you might be talking about profit or you might be talking about cost in a different linear programming problem, but for right now we're just going to use this f of x comma y. So to substitute each vertex, we're going to do f of 1 comma 4. F of 1 comma 4 means I'm going to plug in 1 for x, so 5 times 1 plus 2 times substitute 4 for y. So that's going to give me the value 5 plus 8, so that's 13. And then we'll substitute in the ordered pair 2, 2, which will be 5 times 2 plus 2 times 2. So that is 10 plus 4, so we get 14. And then similar way, we're going to do f of negative 1, 2, which will be 5 times negative 1 plus 2 times 2. So that's negative 5 plus 4, which is negative 1. The last step of this linear programming problem that we're going to do is that we will state the maximum and minimum value of the objective function and the conditions under which it occurs. So we're going to state the maximum and or, depending on what the question asks you for, minimum values of the objective function and the conditions under which it occurs. So we want to look back at the work we just did, and we're going to identify that of the three values, 13, 14, and -1, the maximum value is 14. And the minimum value is -1. So when we state these conditions, I would say, I usually try to use a sentence, so I would say the maximum value is 14 and it occurs when x equals 2 and y equals 2. If I also needed to state the minimum, I'd do that just the same way. So the minimum value is -1 and it occurs when x is -1 and y is 2. It doesn't look like I'm going to have time on this video to go through another example, so I will sign off for now and do an example in the next video.